here's the report. There are 4 basic components to the report that we go through, and I'm going to step you through them here in detail as we go. But the report starts with a satellite image. We're looking down at the property, and you can see here's the primary structure on this property. This is an aerial assessment, right? We've got a bunch of warranty and disclaimer and liability stuff here. But the first stop of the report is to give a top-level summary. And we do that on 3 components. And these are 3 of the 4 components that we'll get into as we go through it. But first, at the summary level, we do the CAL FIRE hazard rating. This is the same information that you get in the standard NHD reports, right? What is the CAL FIRE hazard rating for this structure? It is high. Am I subject to AB 38? Yes. We then do a quick pass at the data as it pertains to how does this property look for AB 38 compliance? Well, it's non-compliant. There's a number of reasons why. We're going to get into that later in the view, in the report. But here we tell you that you're in a non-compliant state as it exists today from what we can see in the satellite. And then here's the quick range of potential costs that might be required to mitigate the non-compliance. Next, we look at the vulnerability reduction. So this gets more close to the terms that an insurer is going to look at. What is the susceptibility of this structure to a passing wildfire? And I'll get into that in a little more detail here in a second. But again, we're going to show you a score, or we're going to actually score the vulnerability. We're going to point out the treatments that need to happen to remediate the vulnerabilities that are identified in this report. In this case, there's going to be 6 trees that need to be remediated. We need to confirm the venting is 1/16 of an inch, among some other things. And we provide, again, a cost estimate. So what this report's going to do is it's going to give you some detail on hazard, beyond just the CAL FIRE hazard rating. It's going to provide an AB 38 perspective in data and put the data in terms of AB 38 compliance. And then it's going to put the vulnerability from an insurer's perspective all into perspective. So it's going to show you that, give you the data related to that, give you some analysis to those 3 ends. And then it will provide a cost estimate. The 4th component is a cost estimate as to how to remediate those elements. There's a lot of explanation in here because there's a lot of data, so that the report is meant to be able to stand on its own. So before we get into all of that analysis, we provide the core data that is getting fed into the analytics in the report. And so you can see that here. We start with the image, and we identify through machine learning all of the trees. These green circles represent the trees that are on the property. We provide an outline of the roof line, which allows the system to understand where the walls are. And we provide insight to the defensible space zone. So here you can see zone 0, or the home ignition zone, which is the first 5 feet between the walls, out from the walls in each direction. Zone 1 is from that 5 feet edge out to 30 feet. And zone 2 is from 30 feet to 100 feet. This is how the wildfire world looks at risk, right? From vulnerability and from regulatory perspectives, what you care about is how much fuel is surrounding the structure. How close are those fuels? What are those fuels made of? Are they other structures, or are they trees, or are they structure attachments? And that's what this process is geared towards understanding. So we provide an image so you can see this. Obviously, in a real estate transaction, people are going to be familiar with the property, what it looks like. But this is giving you the first pass at understanding what it looks like from a wildfire perspective. Next, we provide some detail here. I'll point out that the roof material and the exterior wall materials, when these reports are requested, we ask the person purchasing the report to provide us these elements. This allows the report to get more specific. If we do not receive them, we use default values, which are representative of what we typically see in the state. So after we've gone through the image version, now we provide what we call the property schematic. And this is a little more finite view of the property. This blue line indicates the property parcel. This is important from an AB 38 perspective and also from a mitigation perspective, because this allows us to understand what fuel sources surrounding the structure are on the property and therefore within the purview of the property owner to mitigate, right? While AB 38 is only concerned with fuel sources and trees on the parcel, an insurer might care about the presence of fuels that are off parcel and therefore not within the ability of the property owner to remediate. So we give both perspectives here. So this is the property schematic. And what's interesting here is you'll see solid lines indicate trees that are on parcel. It's hard to see probably through the zoom, but these circles out here represent trees that are off parcel. We give some basic statistics, right? There are 29 trees in zone 0 to zone 2. There are 34 trees in total on parcel. There are 2 structures in zones 0 through 2, so S1 and S3. So that's your property schematic. That's the data, the core data set that now gets fed into our system. The first stop here is the wildfire hazard ratings. This is important on multiple levels. First and foremost, as most of you know, this is what drives AB 38. And any property in a high or very high fire hazard rated zone is subject to AB 38. Now, we provide 3 separate hazard ratings because hazard rating also has a big role in insurance underwriting. Generally speaking, insurers will not use these publicly available hazard ratings, but will use proprietary or commercial hazard ratings. What we want to be able to do is represent here the fact that, in general, hazard ratings are qualitative in nature. There are various algorithms and data that get fed into them to identify the wildfire risk of a property in a given area. The hazard rating really speaks predominantly to the likelihood of a wildfire passing this structure, right? And so you can see here with CAL FIRE, not only do we give the rating, the high rating, we tell you if it's an LRA or an SRA, that's the state responsible area or a local responsible area, all of which would line up to how CAL FIRE manages and communicates fire risk across the state. But we also identify how far away you are from the nearest higher zone, right? So in this case, you can't see it in the map view because it's outside the map view, but the nearest zone is 4.2 miles away. We also now, the second hazard map that we show is the USDA rating. This is the Department of Agriculture. It's what the U.S. Forest Service uses. The underlying data is slightly different from what CAL FIRE uses, although they're usually pretty well correlated. The USDA is looking at fuel sources predominantly. And you can see here that the rating from the USDA is moderate, while the CAL FIRE rating is high. The USDA gives it a moderate rating, but you can see it's very close to a high zone and not too far from a very high zone. The USDA map is created in a different way, so we can't calculate the distances in the same way that we can with the shapefiles with the CAL FIRE map. But visually, you can see here what the hazard rating looks like. Next, we use CPUC. This is the California Public Utility Commission hazard rating. This is another good one because, like the USDA, they use a different methodology. What they are concerned with is understanding the fire risk of the utility infrastructure across the state and what risk that represents for wildfire. So you can see here, they've got a slightly simplified view. They go accepted, elevated, and extreme. The property here is in an elevated, the mid-range, and it's 8.5 miles away from an extreme zone. So what you can see here with this data, right? You've got elevated, you've got moderate, and you've got CAL FIRE with high. This is not atypical. It's pretty typical for us to see multiple hazard zones. The purpose of putting this into the report this way is to help the report purchaser, either the homeowner or the listing agent, to understand the different perspectives around hazard, right? It's very clear what this means for AB 38, but from an insurance perspective, right, just because CAL FIRE says it's high doesn't necessarily mean that the other folks are going to see, the other hazard ratings are going to see high risk here. You've got moderate and elevated risk. What that should tell you is that there might be a chance to find admitted market, standard insurance market offerings for this property, right? That's the projection here. But no matter what, the purchaser of the report will have a very good understanding of the hazard at this point. So that's the general risk. So now that we know the general hazard here and the fact that we're subject to AB 38, now the next part of the report is geared towards understanding regulatory compliance. This is an indication, right? The only way that you will know if you are compliant is if CAL FIRE comes on site and does their inspection, or a local agency that has responsibility. But what we're going to do here, we're going to present that data, the core property data, within the context of AB 38 and how AB 38 evaluates the wildfire vulnerability of the particular structure. In this case, what it looks at, the first thing that AB 38 looks at is that the roof must be a Class A roof. In this case, we've got a default value here. It does look like it's an asphalt roof, so it's compliant. Now we go through zone 0 risks. For zone 0, you need to remove all trees and trim back branches, and you can't have any branches overhanging the structure. Well, you can see here, the trees marked in red are trees that qualify as zone 0 trees because they have branches extending into zone 0. And you can see quite clearly that none of them are intersecting the roof, even though this tree 1 looks like it's getting close. So you can see from this aerial inspection that they're probably going to have non-compliance of these branches in zone 0. There may well be vegetative debris that we can't see here, but at least we know that there's some issues with the branches. Now we'll go into zone 1. Zone 1 rules are that this follows PRC 4291, right, where you have to have separate canopies by 10 feet and all trees need to be limbed up 6 feet from the ground. Well, we note that there are 4 total zone 1 trees here. The zone 1 trees are in orange. And in looking at this, you can see trees 9 and trees 4 are very well separated. But you can see here that 6 and 3 clearly overlap and that there will need to be some work done to trim those back. In any case, all 4 of those trees may require the limbing up from the 6 feet up to meet the standard for CAL FIRE. But you know that you can see here very clearly that you're going to have to handle at least tree 3 and tree 6. Similarly, zone 2 has very similar fuel separation and continuous tree canopy guidelines. Here, the report shows you that you've got 20 total zone 2 trees. All it takes, these trees are represented, there we go. These trees, the zone 2 trees are represented as yellow. And you can see trees 5 and 7 overlap. Trees 13, 19, 15 overlap. 12 and 15 are tangentially connected. 21 and 189 look like they overlap. So you've got a bunch of trees, multiple trees here that are going to more than likely require some work. Interestingly, this tree 26, if you guys can see it, it's a dotted line. That is an off-parcel tree. While its branches extend on parcel, the tree itself is off parcel and therefore is not subject to AB 38. So all of that data is here. It's presented as data and then laid out in the context of AB 38. Again, getting back to the point of the report. The point of the report is to provide the wildfire-related data in a clear, concise way so that the participants in the real estate transaction can understand the state, right? It's not just subject to what CAL FIRE comes back. It's not just subject to what the insurer or the broker says. We are empowering the people involved in the transaction to understand from themselves and to make decisions from their own perspectives and the data as they can see it. So that's AB 38. We do provide the full context of all of the AB 38 requirements here, going from the structure itself and then zone by zone. We do that, and we do it in terms of IBHS. So this is the beginning of the transition from AB 38 and compliance and into insurance. IBHS stands for the Insurance Business Institute for Home, or the Insurance Institute for Business and Home Safety, sorry. These are the methodologies that the insurance industry is adopting. IBHS works on behalf of insurance carriers and reinsurers. It is very tightly integrated with the approaches that CAL FIRE has established. So it is aligned to what AB 38 says, but the perspective of an insurer is different. They have their own proprietary requirements. IBHS seeks to standardize those. So the idea is that you look at these standards, and if you can meet the IBHS standard, then you will be lined up with the discounts that the California Commissioner of Insurance has required carriers to offer. So this gives you a very clear understanding of what those specific elements are. Again, the data is provided to help you understand where and how the property may or may not be meeting these standards. But this is the top level roadmap. So now we're going to get into vulnerabilities. So we're going to use the same basic methodology, looking at fuels in zone 0, zone 1, zone 2. Our system actually also looks out from zones 100 to 300. And what we're going to do is we're going to show you the score of this property. Now, the mechanism here, we're looking at the same set of data, but the mechanism here is our vulnerability scoring model. And what that model does is it looks at all the fuels, all the trees, including the other structures surrounding the main structure in question, and it calculates the heat output from all of those fuel sources igniting at once. So we create the maximum output of heat, both in the form of radiant heat and convective or flame touch, as well as embers. And we project embers flowing onto the roof and embers being cascaded onto the walls. And what we do is we calculate whether or not there is enough heat, given these fuel sources and given the materials of the structure as we know them, to cause ignition. And we look at this in 5 different threat vectors. So convective heat, are the fuel sources close enough that in a peak fire scenario when everything's burning and you've got a peak wind condition, will you get flame touch? And any score in any of these threat vectors indicates that you've got ignition. So you've got convective heat ignition here of 35. You also get radiant heat ignition, 18 points, so fairly low, about half the score of what you see in convective. You do have ember entry risk, fairly high risk, and you do have risk from other structures, that S3 as we go through. The ember accumulation on the roof does not pose a threat. So the roof is good. And as we saw, the roof was compliant with AB 38. But what this assessment summary does is not only indicate the risk, but it also indicates the treatment of 6 trees. Trimming of limbs and other mitigation services are recommended. But secondary structures identified as S3 should also be considered for mitigation. And as we'll show you, if you mitigate those 6 trees and mitigate S3, you can bring this score from 113 down to 0, which means that you have reduced the vulnerability of the structure very much in line with the standards of IBHS, and you have a very protected, very well protected structure in the event that a wildfire passes. So the next 7 or 8 pages provide that detail. And this, hopefully folks wouldn't ever need to go into this in great detail, but it's here. This is the convective analysis. What you see are 9 boxes, and each box represents a wind direction. This is a wind direction from the southwest to the northeast. And you can tell that because the curved side represents the side of the tree that from where the wind is coming from. And the flat side represents the flame length, given the topography and the wind and the peak wind scenario. What this is telling you up here is in this wind condition, these 3 trees on the south side of the structure are going to create flames that will touch the structure. And we can assume if they're going to put flames onto the structure that by hook or by crook, they will cause the structure to ignite. Even if the structure is made out of a really flame-resistant material like stucco, you have to think about the frames around the window. You have to think about the glass in the window. If it's a single pane glass, glass will crack very quickly. You think about the overhangs on the eaves, right? While the structure can be stucco, the eaves are going to be more than likely to be made of wood, or the connectivity between the eaves and the gutter will be made of wood. What our system does is it understands the lowest threshold of the structure and calculates the likelihood of ignition based off that weakest point of the structure where the flame touch is going to intersect with the house. And you can see as you look at the different wind directions, when you go from a straight wind from the west to the east, you actually get a couple more trees that cause ignition. But what you see here is that there are 6 contributing trees that are close enough to the structure to cause convective heat failure. Next, we look at the radiant heat. We calculate the top 10 or 20 trees that are creating radiant heat on the structure. We give you some of that data, including the assumed materials of the structure, where those top contributing trees exist. Then we show you, in this case, where the radiant failures are. And while there were multiple points of failure on the structure from a convective perspective, from a radiant perspective, and radiant heat's the heat that you would see, that you experience when you sit under a heat lamp. It's the aggregate heat. You can see there's only one small spot of ignition here on the southeast corner. And this identifies all of the trees, or the top trees, that contribute to that ignition. So while convective had a bunch of different failure modes, radiant just has one. And again, we show you some data around those elements. Next, we look at ember entry. So this is about the embers projected from all of the trees onto the structure. When the house is red, that means that there's enough embers being projected, given the assumptions of the report, that you're going to see ignition. Again, very much similar to the convective heat, we identify the key trees. They are the same basic trees. We make an assumption here that there's 1/8 of an inch screening on these. What this report is saying, that there is a volume of, there's a high enough volume of embers being projected on the walls of the structure that even with 1/8 of an inch screening, you are going to have enough embers to project ignition, that there will be a surplus in a number of these wind conditions. Not all, right? In these wind directions from the northeast and from the north, there won't be enough. But when you look at this from the west, there will be. So the model is extremely accurate and precise in its projections. We look at same sort of concept. We look at the embers landing on the roof. We make an assumption that the roof is clean of debris. And in the event that it is clean of debris, that meaning there's nothing in the gutters, nothing on the roof that could ignite beyond the shingles or the roof materials. In this case, you're not going to see any ignition. There isn't enough ember and heat thrown onto the roof to cause that ignition. Lastly, we look at structure to structure, right? And here, as the physics tell us, any structure within 30 feet represents an ignition threat, right? If that little structure were to catch on fire, it would create enough heat on the northeast corner of the house to cause ignition. So that is identified here as well. So now the vulnerability we are showing in this case, if you follow the mitigations outlined below, we get, in fact, with this structure-to-structure mitigation, you will take this, the score from 113 all the way down to 0, even though this is showing 13 here. We show you the schematic with the elements that need to be mitigated. And then we show you the lists of services of elements that need to be mitigated. Now, again, this is a satellite imagery report. To understand the full set, you're going to need to have somebody go on site and do inspections around the actual vents where they are. But this gives you an initial understanding of how a carrier is going to look and care about this property. So then with those analyses done, now we're going to look at cost, right? And so we identified 4 total trees in zone 0 that are either going to need to be removed or remediated on some level. We give ranges. These ranges are based on estimates from the thousands of inspections that we've done across the state. These are very conservative. If you remember, we identified 6 or 7 trees in zone 2. These are the costs based on 1 or 2 trees only needing remediation. So these cost estimates are very, very conservative. Again, they're meant to be an indication of the potential costs, not an exact quote of the costs. Again, here, the vulnerability on the mitigation services. So what you would need to do, the 6 trees that are creating the convective risk, when you clear those 6 trees, you clear the radiant exposure, so there's no risk there. The structure-to-structure risk, you're going to need to go on site and see exactly what's going on with that little structure to remediate it. Vents as well will, any structure prior to 2010 will require some vent work. And there may be other zone 0 work. We also provide the estimated cost for a protection plan. The IBHS standard, in order to become a certified wildfire protected home, one of the things that they require is that the property is monitored and re-inspected annually to make sure that it is kept compliant to the IBHS standard wildfire season after wildfire season. And so we provide a sense of what that would cost. So that's the report. You can see it's 20 pages of data. We provide some glossary and some explanations on the backside here as well.